In our solar system, we have a problem, a plague on all our planets and moons.
The inner solar system's like a shooting gallery. It is a clear and present danger.
Craters, impact sites, everywhere you look.
If a big one hits, we all die.
The offenders? Asteroids, lumps of rock, metal, or both. Some older than the Sun. Many from the asteroid belt, a teeming mass of rubble lying between Mars and Jupiter, pieces of a planet that never formed. And comets, remains of the early solar system, lumps of ice and dirt from beyond the planet Neptune.
But the thing about asteroids and comets is that they're small, so they have orbits around the Sun that can change. Now, obviously, no orbits are circular, they're all elliptical, but the planets and most of the asteroids and comets have orbits that are very nearly circular. But if you perturb one of those, that ellipse can become much, much more eccentric, much longer and thinner. And that can bring asteroids and comets quite close into the Sun. Now, if that happens, of course, then planets and their moons can get in the way. And that's when we get hit by stuff.
So why does the Earth appear to have no craters? Are we somehow special?
Well, the reason that there appears to be a lack of craters on the Earth is, of course, because of our atmosphere. When a small object hits the top of the atmosphere, then the air resistance slows it right down. The object will either burn up through friction or break up. Well, the atmosphere protects us only from the little ones. Of course, it has absolutely no effect whatsoever on the big ones. But even when you do blow a crater on the Earth, the wind, the rain, erosion, all those weathering processes all combine to wear it away again.
So what would happen if we were hit by a big one?
An asteroid would be hitting the Earth at somewhere between 15 and 20 kilometers per second. When a 10-kilometer sized rock hits the ground, the rock itself simply vaporizes. So what you get is a nice big explosion under the ground. That blows a crater, and if your rock was about 10 kilometers across, you'd expect a crater about 200 kilometers wide. The heat and the blast from the explosion itself is going to take out, well, certainly the area of a large country. The material blown out in that explosion is what really does the damage. You set the sky on fire, which means on the ground underneath, of course, you're under the grill. And it'll also set fire to forests and brushland globally. The smoke and the soot from those brush fires then combine with the dust that was blown out in the atmosphere to simply blanket the planet. Add all of that together and we have a really bad day.
The last time this happened, it wiped out the dinosaurs. Is there anything we can do to avoid the same fate? The first step is to scan the skies for anything that could pose a threat.
But what we're actually looking for, of course, is something that moves. Asteroids look like stars, but because they're members of the solar system, they move relative to stars. Now, what I've got here are 3 images, all of the same bit of sky, but those were taken 2 or 3 minutes apart. And if we get the computer to stitch those 3 together, align all the stars, and then play them back one after another, well, can you see the object move? If you look very closely, that fella there. Once we've found one of these things, then clearly the next thing we need to know is where it's going.
So far, we've discovered many thousands of these near-Earth objects. The majority of them should give us little to worry about, but currently there are over 200 that we have classified as potentially hazardous.
One's called 2004 MN4 Apophis, about 800 meters across, and in 2029 it's going to come exceedingly close to the Earth but not hit it. But the Earth will change its orbit, and we don't know where it's going to go after that. So there is a possibility that it could hit in 2036.
If we were to confirm one was heading our way, then is there anything we could do to stop it?
But once you know what its physical properties are, then you can develop a countermeasure. The first option is to go for the sort of Bruce Willis approach. You know, let's try and blow the thing to bits. All you've done is converted a single, predictable bullet into an unpredictable shotgun blast. The second option is much simpler and much more elegant. All you've got to do is give the thing a tiny little nudge, just enough to guarantee that it misses the Earth. Now, while this is a very rare event, it's the only natural hazard we know of that puts the future of our entire species at risk. But it's the one natural hazard that we can predict, and as we've discussed, we can make it go away.